In previous videos, we showed that the tensor is one representation of the Poincare algebra. Poincare algebra comes from the Poincare groups to describe the space-time symmetry in the special relative theory. So, such as a tensors represent as integer spins only, but there are some other spinor which has some half-integer spin as a representation of the Poincare algebra. So we denoted the Lorentz groups or at R plus with up arrows. Plus means that the determinant is equal to 1 and up arrow is the 0, component of the transform is positive. And there's another some groups SL2C, which is partial linear groups with the complex components with the 2x2 matrices. And such SL2C is actually the universal covers of the such R plus up arrows proposed orthogonal Lorentz group. So there are some other example of the universal cover. Universal cover. For example, there are SO3 groups and SO2 group. There are the different group in the manifold because there's some identity in the SO3, but it corresponds to the 1 and the -1 in the SO2. So there are the homomorphism between the SO3 and SO2, but that are not isomorphic in the algebraic group point of view. But in the algebra, if we assign the some real algebra of each of them as an exponential of the generator, that is the same real algebra, same commutator relation as angular momentum commutator relation, and the Pauli matrix are the minimal representations of the such as SO3 and SO2 real algebra. So they are different Lie groups, but they have the same Lie algebra, such as which have such relations groups. There are some universal cover, and it is a similar behavior between the SI2C and the plus minus, such as special linear group and the Lorentz group. There's some identity in the Lorentz groups, but it is corresponding to the SI2C, the 1 and the -1 elements. So there are some homomorphism, and they have actually the same Lie algebra. And such as SI2C contains the -1, so there are some spinor objects can be represented in the such as SI2C group structures. So there are some techniques about how to derive some spinor thing, but I will skip that. There are some homogeneous operator and expanding about the Pauli matrix basis, and such a component can be represented as thrice. And we can construct such space-time components as transformations as some twice of the Pauli matrix, and it will be converted in the gamma matrix in the more component representation of the spinor, but I will skip out in here. And also, in the Poincare algebra point of view, there are some boost generator. So for example, there are some capital gamma and A, where the gamma is a boost generator and A is a translation parameter. It can be represented as exponential I is a boost generator and some antisymmetric infinitesimal parameters to omega, and there are momentum operator the transport to express some translation, and there are some space-time translation. And such a boost generator M can be decomposed at the spin operator and the Lorentz boost operator K. And if we reorganize the J and K linear combination, J plus minus IK is equal to the S12. And that is actually the 2 SO2 galactic products of the 2 SO2 subfields. And we can interpret it as its representations are actually the NMM because the SO2 has the same commutator relation as series. So there are some angular momentum is the commutator relation, and one quantum number can be represented as an and another SC2 quantum number is represented as an arm. And for example, 0, components correspond to the scalar, and the 1/2 zeroth component such a representation corresponds to left-handed bar spinor, which transforms like that. Thus, R is defined as some twice of the products of the gamma matrix or power matrix, and the zeroth 1/2 is correspond to the right-handed bar spinor. There are some two component spinors, and if we consider direct sum of the left-handed and right-handed, this is some divisible component spinor. Thus, we can construct the vectors into the spins one representations divided this NM representation. And I want to focus on how the spinor transforms under the Lorentz transformation. First of all, if we start, there are some transform of the transform matrix of the spinors as S, and actually this gamma matrix can be expanded like that. Some transformation of the gamma matrix. There's a gamma matrix gamma mu, and such as is actually the defines the exponential of the I capital sigma, where the sigma is a commutator relation of the gamma mu and the gamma nu, sigma mu nu, and there are some coefficients in front of them. And if we consider that the expansions about this as gamma nu as inverse things, then there are some Lorentz booster factor and gamma mu with the appears. There are some such as gamma nu as -1, such conjugate forms or transforms like that. And if we consider that there's some vector-like objects as adjoint spinor and gamma matrix and spinor, that's actually the vectors transforms around the Lorentz boost will show that. Actually, the such adjoint spinor is defined as a Hermitian conjugate with the gamma juice. And such as transformation is actually the element of S2C, transform of the such special linear matrix. And if you consider that the Lorentz transformation of this observer, then in from burst transform of the spinor, such as adjoint and S inverse will appears, and also S and the spinors will appears from the 1 and from 2. Mu can be expressed as Lorentz transformation, and the S gamma nu S inverse as like conjugate form. Then such S inverse S and S inverse S will disappear. So such objects will be transforms like the vector-like. So such adjoint gamma means and the spinors are called some vectors objects constructs from the spinors and gamma matrix. And also you can see that the adjoint spinors and the spinors transforms like this color. That's invariant under the Lorentz transformation, and such as adjoint spinors should be defined to construct the scalar objects. Such as Lagrangian should be the Lorentz invariant such as scalar. So if we construct the Lagrangians from the spinor, there will be some such adjoint spinors and spinor terms will appear as a mass term, and such a vector-like objects, there will be the multipliers of the partial mu, then the does actually correspond to the Dirac equations, and if we multiply the sum of the gauge boson field from this vector-like objects, then it represents as some covariant derivative terms, which is represents some gauge boson interaction thing. So the point is that we can construct some scalar object and vector objects from the spinors and using the gamma matrix, and it can be used to construct some Lagrangian from the spinors and gamma matrix. There are some transform of the twice the Gamma matrix on the asked form to represent some of the space-time transformation. And we can construct the various spin not only the integral spin, there are also half integral spin. For spin is equal to 0, there is actually the Klein-Gordon. Just the relativistic versions of the Schrödinger's equations in quantum mechanics. And also we can construct some spin 1 free particle equational motions as such a form, and then such as one of the last case device, but I didn't discuss in here. And also we can construct the Dirac equation from the such a term vector like the partials mu in the Lagrangian. It is the such a Dirac equation, and actually it will be the reduced in the Klein-Gordon equation if we multiply the I gamma mu partial mu plus this in the left-hand side. And the S equal to the spin is 2 over 2 spins, and the Lorentz-Schwinger equation. The additional spin induction in here. Also, we can construct the spin 2 free particle for the gravitons correspond to matter in the general relativity theory, and so on. So we can consider on higher spin 2. So, such as some spin into the spin and half into the spin is actually the representation of the Planck current groups, and the especially the spin with the Lagrangian with the spinors can be constructed by using the gamma matrix to describe the transformations of the spinors under the Lorentz transformations.